Okay, so hello guys, welcome back to another video. This is Wave and Coastal Features Part 2. Now, in this video, I'll be looking at wave processes, right? Wave processes. Now, in the last video, I looked on constructive and destructive waves, namely. Now I'm going to be looking at wave processes: erosion, transportation, and deposition, right? So these are the three processes: erosion, deposition, transportation. So, oh, okay. All right. So the first thing that we're going to be looking at is erosion. There are different types of erosion occurring, right, by the coast, right? So the processes of coastal erosion, they're very similar. They're very similar to those that occur by rivers. Now, point of information, rivers will be the next video that will be coming out after I'm finished with waves and coastal features, right? So wave processes: erosion, transportation, deposition. Erosion, right? So the first process that we'll be looking at is what we would call hydraulic action. Hydraulic action. Now, this involves the sheer power of the water as it smashes into a cliff. Now, the trapped air is blasted into holes and cracks of the rock, eventually causing fragments of rock to break off. The explosive force of trapped air operating in the operating in the crack is called cavitation, right? So let me illustrate that. Now, this is a limestone cliff. Let me draw. I'm going to be drawing, right? Or demonstrating by drawing, right? So this is a limestone cliff right here. Jaggy cliff. Now, what happens with hydraulic action, right? As the water smashes, right? It would then, as it smashes into the cliff. So what happens is that the water that smashes, remember that the wind is what causes the wave to occur. The wind is actually what causes it to be such a powerful wave. So the wind that goes with the wave, right? When the wave smashes upon the cliff, right? The wave is then trapped, and it's trapped into the holes and into the little crevices, into the little cracks of the rock. All right, so let me go again. Right? The wave is carried by wind, right? Moving air. So what happens is that when the wave crashes upon the cliff, then that moving air ceases, and then it would be trapped. It's like the wave would push the wind or push the air into those cracks and into those crevices and into those holes into the cliff, right? And it becomes trapped air. Now, as the trapped air is as it's in the holes, then what would happen is that since it's trapped air, you know that the pressure will build up. So when the pressure builds up now, it begins to break, right? So it breaks off, right? So what happens is that the trapped air goes into the holes, into the cracks of those cliffs, and then pressure builds up and then it breaks off, right? Now, the explosive force of trapped air that operates in the crack is what we would call cavitation. So just think of it as a cavity, right? A hole, a cavity, right? So it's called cavitation. This happens when trapped air, when there's an explosive force of trapped air, because of course it's explosive, right? Good. Right. So the next process of erosion that we will be looking on is corrosion. Or other people call it abrasion. Right? Now, this involves the fragments of rock being picked up and hurled by the sea at the cliff. Now, the rocks act like erasive tools, scraping and grinding the rock. All right, so basically, what is happening? Remember in those olden days when people used to do things that are wrong? What would happen is that they would hurl, they would stone them. So basically, that is what is happening. So it's like you have the cliff right here, right? This is the cliff. And it's like this is the wave coming in. And it's like it's having these rocks being hurled. Mark you. You would not really see it. Sometimes it's not really that obvious, but you will have these rocks being pushed onto it. It's like it's being hurled sometimes. The big rocks, that is. When I say big rocks, I mean rocks like pebbles. And what they would do is that they would scrape. They would scrape off. They would scrape or gouge the rock, right? So it's like they act as sandpaper, where it's as you're scraping it. And what happens is that when abrasion takes place, the process of the surface of this cliff would then begin to be smooth. It would then be smooth because it's like you have this graining. It's basically like how you're sanding wood. Like you use sandpaper on wood, you know the wood is so rough, and it's like you use the sandpaper and you just sand it down. That's what happens. It's like you have these rocks or these small sediments, because sediments can also occur too. It can also have that effect, right? You have these small particles. You have particles hurling against the rock, grinding the rock, scratching the rock, right? And it grinds off. So think about it. Maybe you might not remember the term corrosion, but remember, you can remember abrasion. Abrasion. When I think about abrasion, you think about something just a gringe off, like it just gringy. Yeah. Right? So that is what happens with corrosion, right? Good. Now the next process of coastal erosion is what we would call corrosion. Now, this is actually an easy one. When something is corrosive, or when something, when corrosion takes place, you know that some form of breaking down occurs, right? Some form of going into some form of, breaking apart occurs. Some form of solution. There's a solution involved in corrosion, right? So some rocks at the coast, right, are especially vulnerable to being dissolved by seawater. And corrosion, right? Remember the video that I did about chemical weathering, right? So corrosion, or what I would say solution, right? It's chemical weathering altogether, right? So example is like you have a limestone cliff, which is of course CaCO3, which is calcium carbonate, and then you have the acidic seawater, or you would have the salt in the seawater, which is sodium chloride in the water. It's dissolved in the water. And some rocks that are by the cliff, right, or some rocks by the coast, they are vulnerable to being dissolved by the seawater, right? Right? So therefore, the acids in the rock, it slowly begins to work chemically on those rocks by the cliffs, right? So what happens is that it would dissolve away the rock. And when it dissolves away the rock, it forms some jaggy something. So it's like the surface of the rock or the cliff face would look so jagged because you'd have the seawater rushing on the coast, and you'd have some rocks or some aspects of the limestone, or you would call some soft rocks that are more vulnerable to being dissolved by the seawater. These rocks, right? So when the seawater begins to dissolve them, then you would notice that the sea would, so it's like there's a sediments, they are being dissolved. And then you notice a jaggy pattern, right? Yes, so that is what happens. Or sometimes what happens is that when the waves come in, right, they cut, right? So it's like this area of soft rock. And what happens is that it undercuts the cliff face. Sometimes that happens. So like this is an area of soft rock, and then this area is more vulnerable to chemical weathering, or it's more vulnerable to being dissolved. So what sometimes happens is that it cuts this section. Sometimes that's what happens, right? Now this is what we call corrosion. The last process of erosion, coastal erosion, is what we call attrition, right? No, this happens when the rock fragments carried by the sea, right? They knock into each other. So they scrape across each other, right? So therefore, this causes them to be rounded and smaller, right? So sometimes what happens is that they sometimes these are fragments that have been broken from the cliffs. So what happens is that they rub against each other, right? So that is basically attrition. Rock fragments carried by the sea knocking against each other or rubbing against each other, right? So rock fragments that have been broken off, they have various ways of transporting it to the sea or to the coast, right? So sediments are moved in waves for a number of ways. Now, this is when we're going to be looking at the transportation aspect of wave processes, right? Now, there are I should say there are four main ways in which. So there are four main ways in which in which sediments are carried by waves. The first thing that we're going to be looking at is traction. Now, when I think about traction, I think about a tractor, because tractor is like, so what a tractor is? Its tractor is like this big, heavy machine. It's like it basically it rolls. So it's like it rolls sand or roll, yeah. So it's like this big engine, like it just, when it's taking off sand, it basically rolling or lifting it from the ground, yeah. So the same principle can be applied. So if you don't remember this process, remember one tractor. It's a roll something, right? So this is where heavier particles they roll along the seabed, right? So it's like they roll. So sometimes these big boulders they roll, right? Not really big boulders, but like those large things that cannot be carried or cannot be lifted. They are rolled along the seabed, right? Now, the next process that we'll be looking at is saltation. Now, this is a process that I like, right? Hop, 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 doing the baby bop hop, right? So this happens, right? They're too heavy. So these are basically pebbles. They're too heavy to be carried by waves, but they hop, right? So it's like psh, hopping, hopping, hop, 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 hop. And they're like hopping. So these are basically pebbles, like small pebbles. So it's like they're hopping. They're hop, jumping up and down, jumping up and down. So saltation is the process by which sediments that cannot be carried by the ocean, carried by waves, right? They move in a bouncing manner. So they're normally disturbed by other particles knocking into them, right? So they normally hop. So it's like they hop, 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 hop. Right? So it's like it's hopping because you have these sediments brushing onto them, right? So it hops, right? Now the next process that I'll be looking on is, give me a minute. The next process is suspension. Now, these are small sediments, very small, light particles, such as sand, that are normally carried within waves, right? So sand is most commonly transported, in these ways, right? So it's like they are light. They're light enough to be carried in waves. So lighter particles can be picked up and carried along the water, right? Next one, dissolved load. This is easy, right? And dissolved load is normally the cause of chemical weathering, or is normally the cause of erosion, as in coastal erosion, specifically corrosion. yeah, corrosion, yeah. So what happens is that dissolved chemicals are transported. Sorry, I forgot load right here. Dissolved load. So it's like chemicals that are in the seawater. They are carried, right, along the coast, right? And oftentimes they precipitate out of the solution, and they go into they go onto the seabed, right? So oftentimes it's happened with limestone, right? Whereas you have a solution, right? So when you have a solution of limestone forming, then by the time it reaches to the coast, it would then form a precipitate, and therefore limestone is formed. So sometimes this happens with limestone formation, right? Now, we're going to be moving on to the deposition aspect. And the deposition aspect, it only requires one process. And this is this big word called longshore drift. Bam. Longshore drift. Right? Now, we often think that waves just go upon the ocean directly and just come back directly. No. If it were to happen that way, no sediment would be left by the coast and no sediment would be washed off the coast. So what happens is that by a coast, right, by a coast, the waves travel at angles, right? They approach the shoreline at angles, right? So one important factor affecting the movement of sediment and its deposition at the coast is the angle in which the waves approach the shoreline, right? So believe it or not, they approach the shoreline at an angle, right? So if the waves approach the parallel to the coast, right, sediments would simply be moved up and down the beach, right? So under these conditions, beaches normally form in bays, right? So normally when it just move up and down the beach, right? Now there'll be little sediments movement along that coast. So basically that happens in bays, right? Now the waves appear or the waves approach the shoreline in a zigzag format, right? Zigzag. So it's like it's coming to the sea like this. Coming to the coast, sorry, like this from the sea. So it's like it's transporting, it carries materials coming back. Carries materials coming back. It's like it's going this zigzag pattern. Yeah. Now, often the direction of the longshore drift is normally this way. So it's like it's going like this. Yeah. But then you have the direction of the longshore drift going this way. So this would be, often this is the swash, right? This is the swash. And then the backwash, right? Swash, backwash. Swash, backwash. Swash, backwash. Swash, backwash, right? No, there's not a specific angle as to where the longshore drift or the as to how the longshore drift approaches the ocean or the beach, right? But you know, it approaches the beach at an angle, right? So if the waves, right, sorry. So coastal deposition takes place in areas where the flow of water slows down, right? So sediment can no longer be carried or rolled along and it has to be deposited. The coastal deposition mostly occurs commonly in bays, where the energy of the waves is reduced upon entering the bay, right? Now, this explains the presence of beaches in bays and occurs for the lack of beaches at headlands where the wave energy is much greater, right? So what happens is that by beaches, of course, you know that the headland would break the waves from, you know, and then when it approaches, so basically beaches are formed by longshore drift and beaches are formed in bays. You notice every bay has a beach, right? Every single bay would have a beach, right? Why? Because there's low energy going into the bay, therefore more constructive waves would occur than destructive waves. However, by the headland, more destructive waves would occur more than constructive waves because by there would be a high energy, right? So it's impossible. Good. Now, I hope you enjoyed this video. Well, before I close, I'm going to be demonstrating I'm going to be drawing. So this would be, then you have the groin right here. Groin right here. Right. So this is the wave approaching it at an angle, right? So this is the swash, right? It doesn't really matter. It doesn't really matter how it approaches, because maybe some shores are different, like they have different angles. But a majority of times the swash is like this and the backwash is like this, right? So you can see the zigzag pattern, right? The zigzag pattern, right? So this is swash, backwash, swash, backwash, right? Now, it's like what happens is like right here, like in these areas where it have the swash, right? Sometimes in these areas you'd have the material being deposited, or in these areas you'd have the material being taken away, right? So the angle of the beach, as I said before, it doesn't matter. It all depends by the direction of the, it depends on the direction, sorry, of the prevailing winds. So like this, it would be occurring this way. The previous time it was occurring that way. My apologies, word of correction, right? So the last time when I was showing the longshore drift, it was occurring this way. Now this time it's occurring this way. Now the direction does not matter, all right? It all depends on the direction of the prevailing wind, right? So I hope you enjoyed this video. Don't forget to like, subscribe, and thank you for watching.